Okay, so we're going over the practice test. Let me just write this down. We're going over the practice test. And we're looking at what? 10 to 13? And this is page 381. So if anybody at home is watching, then we can know what we're doing. All right, so it says in center. So we already started drawing this already. How do we find the in center? What do we do to this angle? We bisected the angles, didn't we? So I bisected all three angles, and they intersected at that point. Now this green line right here, what does that green line do? That's the distance. The special property about the in-center is that the distance from the in-center to the sides, right, from that point of intersection to the sides is all the same. So that's what we were doing. But it has to be what? Perpendicular, doesn't it? Because that's the distance from a point to a line. Has to be a perpendicular distance. So that all has to be. Now, if you look in the book, they don't extend that all the way through here, do they? They just stop right here at the in-center. Just kind of cleans it up a little bit, doesn't it? And that stops right at the in-center, and this one stops right at the in-center. Okay? So that's what it looks like in the book. Looks a little cleaner, doesn't it? Yes, it does, Mr. Hammock. Okay. All right, so what do we got? We got some numbers here. This is 24. This is 25. This is 28 degrees. This angle right there. This one's 30 degrees. And 11 is this side right here. Yep. And let's put some letters in here. This is A, F, and C. This is G. This is B. And this is D. Alright, we're good to go. Now, did I get everything? Oh, the in-center is H. Thank you. Alright, so what are we trying to do first? Find DH. So we're trying to find this one right here, this DH. Now, what do we know? Let's first take a look at DH. Before we actually try to find DH, let's see if there's any relationships between DH and anything else. Is there? Yeah, what is it? All the green ones are all the same, aren't they? Okay, that distance from the in-center to the sides, they're going to be all the same. So if I find DH, it's going to be the same thing as GH and FH. Agreed? But with the information given right here, I really don't have enough information to find DH directly. So what am I going to do? I'm going to try to find one of the other green sides. And can I find one of the other green sides? FH. I can find a FH. And how did I know I could find a FH? Because of these sides that were given. This is 24, this is 25, and I don't know this. All right, let's just call it, let's use one letter. Let's just call it X. Is that all right? So I got to find this one. Once I find FH, DH is going to be the same exact thing. Would you agree? So how in the world do I find FH? Well, first of all, I've got a right triangle, don't I? And I know two sides of a right triangle, so we do the Pythagorean Theorem. A common mistake. In here, I saw it when you guys were working on it, on the study guide and on this thing, and in the other class as well, so you're not the only ones. A lot of people just look at the two numbers and they automatically go 24 squared plus 25 squared. Is that what you do for Pythagorean Theorem? No, not necessarily. So remember, Pythagorean Theorem is a squared plus b squared equals c squared. That's right. That's super important right there. The C is the hypotenuse. Which one is the hypotenuse in this triangle? The 25. So it has to go here. Okay? These are the two legs, right? These two things right here, those are the two legs that are being added up. What are the two legs on this particular triangle? X and 24, right? And so that's how I'm going to set it up. So a lot of you guys did Pythagorean Theorem, but you didn't set it up right. You put 24 squared plus 25 squared equals x squared. But you've got to make sure that you put the hypotenuse by itself. Everybody with me on that? And that comes out to 7, doesn't it? I'll let you do the math. This is actually a special triangle. We're going to have a chapter, and I forget exactly which chapter it is. I think it's chapter 8. I'm not really sure. Where we have special triangles. Did we talk about a 3, 4, 5 triangle in the past? We haven't? Well, we'll talk about that later. But you're actually going to memorize some of these special triangles, and this is actually a triangle that you can actually memorize. So instead of going through all the math, you could look at it and you say, something 24, 25. Oh, 7, 24, 25. Right? And if you work it out, they call it a Pythagorean triple, which means all three numbers are nice whole numbers. Okay, it doesn't always come out to nice whole numbers, but on Pythagorean triples it does. All right, enough of that. So x is 7. So that means FH is 7. So what does that mean about DH? That has to be 7 as well. Now, they don't ask you, but what if they ask you for GH? That would be 7 as well. Okay, everybody with me? All right, so DH is 7. That's our first question. The next one says BD. BD. Okay, so I want to find this one. Well, again, I've got a right triangle here, don't I? And look, I know two sides of my right triangle again, don't I? I know this is 11 because they told it to me, and I know this one because I just found it, right? And so in order to do this problem, you're going to have to be able to do the problem before it and get that right. So this is 7, this is 11, and you could actually solve for it. And to tell you the truth, in that chapter where we talk about right triangles, even if I didn't know this, we're going to learn something later on. You don't know it now, but later on we're going to learn something where if you know this is 30 degrees and you know this is 11, which they gave to you, you could actually find dB on your own. Okay? Isn't that exciting? Yeah. And you're probably wondering, how could I do that with just knowing an angle and a side? Well, you'll have to wait. All right, sorry to get you all excited about it, but right. But right now, since I know this is 7, I can do Pythagorean Theorem. So how am I going to set this up? Let's call this y. So I would do what? Yeah. Let's use the letters and numbers that I have here. So I go y squared plus what? 7 squared equals what? 11 squared. Now, I don't think this comes out as pretty, does it? No. So so y squared equals, what's that? 121. Subtract that, which is 49, right? And then I don't know, whatever that stuff is. All right, let's use the calculator. And what do we got? 121 minus 49, and that's that. And what do I have to do with that? Take the square root of it. So take the square root of my answer, and then 8.48. We round it. So what is it? 8.5. So it's not exactly 8.5, but it's close enough. So that's what dB is. That's one of our other answers. Now, if you put 8.49 or something like that, because it doesn't say to round it to a certain thing. Yeah, so if you put 8.49, that's fine. All right, that would have worked. I've been fine with that. I'm not really that picky, unless they ask you to round it to a certain place, right? Because that's part of the instructions, so you have to round it. But the instructions on this one do not say that you had to round it to a certain place, so don't worry so much about the rounding. All right, let's do the next two are actually kind of easy, aren't they? HAC. Let's go different color now. Let's go blue for our angles. H, where's H? Right there. HAC. So it's this angle right here. That's what we're trying to find. How in the world am I going to do that? Well, what do I know about this whole entire big triangle, the whole big white triangle right there? What do I know about all three of these angles? They add up to 180, don't they? Can I find the other two big angles? I know this is 28. What about this angle right here? Why is it 28? Because this is the incenter. And how'd you get the incenter? You bisected the angles, didn't you? So if this is 28, what's this? All right, with that same reasoning, that same thought process, what else could you say? The 30, right. This 30 and this 30 are the same, aren't they? Because we bisected that angle. Is that going to help you? Well, it's going to help you find that whole big angle right there, isn't it? So let's do that. What's 30, or this would be 60, right? And this would be what? 56? I have to do it right here. Plus 56. And what's that? 116? Did I do that right? Okay, so that's 116. How do I find the big angle A? That's right. So go 180 minus 116. And that's a 4 and that's a 6, right? So that big angle right there is 64 degrees. But that's not what they ask for. They ask for this little angle, HAC. So how do you do that? Just divide it by 2. That's right. So that angle right there would be 32 degrees. Make sense? All right. And that helped knowing that to find the incenter, you had to bisect the angles, didn't it? Because if you didn't know that, you'd kind of be sunk. You might have guessed, but it's nice to know. All right. And DHG, let's find that. Where's D? DHG. So I'm trying to find this angle right there. Well, let's take a look at this. Look what we have here. I've got two triangles, don't I? Now, you might be able to look at it and just make an assumption, but I don't like to work on assumptions, okay? But look at these two triangles. See this triangle here and this triangle right here? Okay, they are what to each other? They're congruent to each other, aren't they? Because look, I've got an angle and a side, don't I? I got a 30, a 90, and this 11. I got a 30, a 90, and this 11. So those triangles are congruent to each other. So what is true about this little angle right here and this little angle right here? They're both exactly the same, aren't they? So what we're going to do, we're going to go opposite of this. We're going to find the little angle first, and then we're going to double it. Instead of finding the big one and taking half of it, we're going to find the little one, and then we're going to double it. Make sense? All right, so let's do that. And that's kind of easy. I got a 30 and a 90. What's this going to be? This little angle is going to be 60, isn't it? Which means this angle is 60. And what's the whole big angle? 120. Okay, so that would be 120 degrees. It's kind of nice, isn't it? See how that congruent triangle stuff helps you out a little bit? And you might have looked at it and just guessed and might have just made an assumption that, oh, yeah, they look equal to each other, but you don't want to do that. You want to know exactly why they're equal to each other. And I just showed you. How's that? All right, good. So that's in center. Was there one with a centroid on this? There wasn't. Oh, the first one. Oh, okay. They didn't really give you. Oh, yeah, they did. Like 2 through 4. Are you okay with the centroid thing? How do you find the centroid? What is it? The median. What is the median? You go from a vertex where? To the midpoint of the opposite side, okay? And remember, the centroid is that one where the one side is double the, right, the longer side is double the shorter side and all that kind of stuff. I wish I could. I want to think of ways to remember these all the time, and I can't think of a nice, easy way. Google it? I don't know. Every time I've seen several videos of people teaching this stuff, and they don't have like a nice pretty way to remember it. They say, this is the in-center, this is what it does. This is the centroid, this is what it does. And they don't have like a little cutesy way to remember it. You know what I mean? Like, my dear Aunt Sally, you know, that kind of thing. Please excuse. I saw on Facebook yesterday or something that somebody posted, I don't know, some website or something had like a t-shirt, and it had some lady's name on it. Or it had some lady's face on it, and it said, please excuse my dear Aunt Sally, or something like that. And I guess it's for geeky math teachers to wear around. Like me and Mrs. Bonsbach. She would love that.
You're still recording.
Is that right? Okay, that's all right.
They won't understand what you're talking about.
That's fine. Is there anything else? Are we good with the other stuff?
Yeah.
The range between those two numbers, that's easy. Yeah, my goodness, this should be a good test for you. You think? I hope so. Well, it's difficult. This was difficult?
Yeah.
It was? I don't think that was so hard, was it? What about the thing that's greater than, when they give you the two triangles and, you know, the two angles, you look opposite the bigger angle, that's the bigger side. Everybody okay with that part? You sure? I just want to make sure that we cover all the bases and you don't just sit there quiet and don't ask me a question. Right, the only proof. There's only one proof, and it's an indirect proof, and we kind of talked about that earlier. No. It should be pretty easy, I think. The thing that scares me is that I looked on the computer and I had Chapter 5 test, and then I had a Chapter 5, like, what would I call it? I had like a second test. What do you call it? Like not a practice test. Like a redo test. I didn't call it that. I'd call it something. But I'm thinking, oh, I must have made that because they did bad the first time, and then I had to give them another one, like a retake. That's what I called it, a retake test. But I don't think we're going to need a retake. I think you guys will do fine the first time. Hopefully. Any other questions?
Okay. On the test, how many like assume?
I think there's like 2 of the things where it says assume. Yeah. Okay, what I thought we would do, let's go question by question on what type of problems are going to be on the test, okay? So that you have no doubts whatsoever what to study, okay? So 1 to 3, it's basically what we just did, that in-center thing. And I'll even tell you, it's all about the in-center, where you have to find a missing angle, missing sides, and all that kind of thing. All right, I am recording this. All right, 4 and 5 is circumcenter. Same kind of deal. I give you a triangle. I tell you that it's a circumcenter. And then I ask you a couple questions, find the length of this and all that kind of stuff. All right? How do we find the circumcenter? Do you remember that? Perpendicular bisector, do you remember that? So for circumcenter, do perpendicular bisector, and what's true about that? It's equidistant from the vertices, okay? And we talked about that quite a bit yesterday. It was one of those problems. I forget. I'm trying to remember what problem we were talking about. But anyway, so circumcenter, you can look that up. Okay, 6 through 8 is centroid. And they're all very similar to each other, where they'll give you a picture. Okay, it's all drawn out for you. You don't have to draw it and find it. It's all drawn out for you, and it says this is the in-center, this is the circumcenter, this is the centroid. Then they're going to give you some numbers, give you some angles, and they're going to ask you to solve for certain things. Yes? You will not. Nope. You won't have to do any graphs. Actually, I just lied to you. I didn't lie. I just didn't see it. Number 9 is one of those, okay, where they give you ordered pairs. They'll give you 3 ordered pairs, which makes a triangle, obviously, and you have to tell, I'm not going to tell you which one it is, but you're going to have to either find the in-center, the circumcenter, or the centroid, okay? So you will have to graph it. I'll give you a little graph on your answer sheet, okay, little X and Y axis thing, little boxes and all that, you know what I mean, little graph paper thing. And so you just find one of those. I'll say, here are the ordered pairs, find the in-center, or find the circumcenter, or find the centroid, okay? The centroid is what? What do? You got to look on that chart. Remember what that chart is? Where that chart is? It's page 337, I believe. Okay? So how do you find the centroid? Find the what? The median. Okay? How do you find the circumcenter? Find the... That's the one that we did. No. Oh, that's right. Sorry, I was thinking of the next one. This is perpendicular bisector. Okay, so this is median, this is perpendicular bisector, and this one is angle bisector. Okay. Yeah, you got to find which. Yeah, where is the? Yeah. I'm not sure what you're asking. I've already told you what these are all about. Okay, this one right here, they give you 3 ordered pairs, and they're going to say, tell me the ordered pair, or tell me the, what do they say, the coordinate of the in-center, or tell me the coordinate of the circumcenter, or tell me the coordinate of the centroid. And so your answer is going to be an ordered pair. Okay. No. Nope, I'm telling you, that's all that stuff. I just told you. You keep asking the same question. I'm not sure what you're not getting. You just have to find where the ordered pair is. No, I explained those already. They give you everything. They give you the picture. Go back and listen. I've said this before. Well, I'll say it again. They give you the picture, and they draw the in-center, and they draw the circumcenter, and they draw the centroid. All right? Just like this. Just like this. They draw this, and they give you some stuff, and they ask you some questions. Okay, what is... All right, it's just like that. No, I said for all of these, for the in-center, circumcenter, and centroid, they're all very, very similar to each other. Okay? All right, let's keep going. 10 and 11 is where they give you the triangle, and they say, list the angles and sides from the smallest to largest. So from the smallest... You've done a lot of those. You know what I'm talking about? Okay, so that's 10 and 11. 12 and 13 is where you state the assumption. So that's easy. So there's 2 of those. To an indirect proof, right? And that's all it says. Just state the assumption. You don't have to do a whole indirect proof on it. Just read the instructions, and it'll say, state the assumption. Number 14 is your indirect proof. It's your only one. It's a very simple, basic one. It's nothing real complicated. We already went over one today earlier, so it's going to be simple like that. 15 and 16 is going to be, is it possible to form a triangle? Is it possible to form a triangle with those lengths? So I give you 3 lengths, and you tell me if you can make a triangle. Yeah, you take the 2 smaller ones, add it. It's got to be bigger than the third side. Okay, so there's 2 of those. All right. 17 is find the range of possible sides lengths for the third side. I'll just, yeah, this is where you just subtract them, you add them, you put less than, okay? That's that one, find the range. Okay, then 18 through 20, it's the triangle inequality ones. I'll just write that, triangle inequality. Right, that's where they tell you one side is bigger than the other side. All right, and then so what do? You look opposite, so the angle opposite the bigger side is bigger than the angle opposite the smaller side. Remember that? So they'll say compare triangle ABC or angle ABC to triangle or to angle whatever DEF, yeah, whatever. Okay, and then you got to compare them. So what do you just say? You say, well, it's either less than, it's greater than, or it's equal, or whatever. And that's 18 through 20, and that's your test. Should be pretty easy, shouldn't it? Right? We've covered all this stuff. I mean, this is the hardest part, so make sure you go through, make sure you remember how do you find the incenter, how do you find the circumcenter, how do you find the centroid, and what is the what's the special relationship, you know, at that point. What does the incenter do? Well, it's equidistant from what? What's the circumcenter? It's equidistant from what? What's a centroid? Right? The longer one's twice as big as the shorter one. The longer one's 2/3 of the whole thing. All that good stuff. Okay, everybody good?
Yep.
All righty.